to Grade 2, Chapter 11, Geometry. So for our first activity today, we will be coloring a bunch of shapes. We will be also learning about solid shapes, and you might want to use crayons or pencil crayons or anything that you would like to color with. The first question asks us to color the cone red. So first we need to ask ourselves, what is a cone? Well, what do you think of when you think of a cone? Maybe that yummy ice cream cone that you eat in the middle of the summer, or maybe even winter. So what does an ice cream cone look like? Well, the cone part is the crunchy part, right? So the crunchy part looks somewhat like this. And that's a cone. So which of these looks most like the cone? Well, you see, when you turn an ice cream cone upside down, then the bottom kind of looks like this shape right here. So now we realize that that's called a cone, and this shape looks like the cone. So this shape should also be called a cone. And yes, it is called a cone. So now let's color the cone red. Coloring the cone red. Alright, the second question asks us to color the pyramid blue. Now, have you ever seen any books about Egypt or the mummies? Or if you've ever been to Egypt, you would know that there are these things that they call pyramids. They look something like this. So there's a triangle, and then another triangle, and then you can't really see what's behind it because it's a solid shape and you can't see every side of a solid shape. So which of these shapes looks like a triangle with another triangle? Well, you see, there's a triangle here, and then another triangle here, and that looks somewhat like what the pyramids pictures show us. So why is a pyramid called a pyramid? Well, because it looks like a pyramid shape. So if the pyramid looks like this shape, and the reason why it's called a pyramid is because it looks like the shape, well, this one's a pyramid. This is a square-based pyramid. We'll be learning about different types of pyramids in later grades, or we'll be learning about different types of pyramids in later lessons. So for information for now, this is just a pyramid. The next question asks us to color the sphere green. What is a sphere is a big question right here. Well, you see, we've all seen spheres in our life. If we've ever played with a ball, we have seen a sphere. In other words, a sphere is a ball. So a ball is round, right? It looks kind of like a circle, right? So which of these shapes looks like a circle? This one. So let's color that green. Question number 4 asks us to color the cube yellow. We've all played with blocks before when we were a kid, or at least most of us have. And there's these cubes. We've also all played with those cubes that join together. So what do they look like? Well, they're equal on all sides, and every side of them is, well, a square. So does this one have every side of the square? Does this one have every side of the square? Or does this one have a square? This one doesn't even look like it has a square. And that one definitely doesn't look like it has a square. And this one looks like it has a square. And because this is a solid shape, squares may not really look like squares depending on which angle you look at them from. So since we realize that that is a cube is made out of 6 sides of squares, then we'll color it yellow, because that's what the question asks us to do. Question number 5 asks us to color the cylinder purple. So what is a cylinder? Well, you've seen poles outside. A pole is a very, very long cylinder. What else is a cylinder? A roll of paper. You know those tissue papers that come in rolls? Yeah, that's also a cylinder. So what do they look like? They look something like, well, this. So, which one of these shapes looks like that? That one. So a cylinder has a circle at the bottom and a circle at the top. And then the other bit of the cylinder is curved. So now let's color this one purple because the question asks us to. Finally, we're at the last question of this exercise. Question number 6. Color the rectangular prism orange. There's only one left. But it's better to know why exactly it's a rectangular prism, right? So, a rectangular prism is made out of rectangles. Wow, right? So, continuing, this one has a rectangle, another rectangle, and the other sides back there are also rectangles. So, now let's color this one orange. Question number 7. Yay, we're done that exercise. Now we're on this one. Draw a yellow line around the cone. I'm quite sure that by that they mean circle, because you can't really draw a line around anything because the line is straight. And if you draw something around something, then that's not straight, that's curved. So, draw a yellow line around the cone. Then, draw a red line around the sphere. This is an ice cream cone! Yay, we saw that before, right? Which part of an ice cream cone is the cone? The bottom part. So, since we know that this is a cone, we circle it. Well, we draw a yellow line around it. And besides, cone have a circle, and then this curved triangular bit. Then draw a red line around the sphere. Spheres are like balls. They're circular. So which part of this drawing of an ice cream cone looks circular? It's the ice cream part. If you've ever used an ice cream scoop and scooped out ice cream from a bucket, tub of ice cream, you know the feeling. You know that they are spheres. So, let's draw a red line around the sphere. Whee! We're finished question number 7. That was quick, wasn't it? Now we're on question number 8. Find the cubes in the picture. Draw a line around them. Let's go down for a better look at it, shall we? The cubes in the picture. Now, what do we know about cubes? Well, they're made of squares, right? So then we find the squares in that picture. It says draw a line around them, so I'm just going to use red. Because why not? There seems like there's a square here. So, oh look, there's a cube. Now, this one may be a square, but it looks a little bit too long and a little bit too short on this side. So, it probably isn't a cube. Therefore, there's only one cube in this picture. We're finally finished section number 1. Hooray, give yourself a pat on the back. Now we're on section number 2 of chapter 11, where we will be teaching you about faces, edges, and vertices of solid shapes. Preparation? We also need crayons, or you could use a pencil, anything to write with. So, what are faces, edges, and vertices? What are these strange words that you are seeing right here? Well, here's a diagram to explain it. A face is a side. Faces are sides. So it is an entire side. Think of this as a room. A face would be a wall, or the ceiling, or the floor. And then there's the vertices. Those are the corners. The moment you see that there's 8 vertices for this is a cube, you can see the square. The moment you see the word 8 vertices, you may be thinking, 8 corners? There's not 8 corners of a room. But really there is. You only see 4 corners is because you can't float up to the ceiling. If you can't float up to the ceiling though, or jump up and somehow stay up there, congratulations, that's very dangerous though, don't do that. And there's 12 edges. Edges are where the walls meet, or the faces meet. I'm not sure what you guys would call them. They're not corners exactly, but they're not like walls or floors or ceilings. They're more like when you hide in a corner, you're actually facing the edge, but you are hiding in the corner. Like, so think of it like this is you in the corner, and then you're looking at the edge right here, but you're also hiding in the corner. So you're looking at the edge, but you're hiding in a vertice. And you're standing on a face because it's the bottom. Now that we're done that comparison, let's move on to the exercise. Write how many faces, vertices, and edges are in each solid figure. Question number 1, we have a solid figure over here. Now what solid figure is this? Come on, I'm waiting. Alright, so it's one of those things that look like it's in a picture book. It's a pyramid, guys. So, in a pyramid, how many faces are in a pyramid? Well, we count. 1 triangle, it's a triangular face. 2, 3, which is the floor. 4, which is that wall at the back. 5, which is that other wall at the back. So there's 5 faces of a pyramid. Now we move on to vertices. How many vertices are in this pyramid? Or, if you think about it, how many corners are in that pyramid? So there's this one over here. There's one over here. And then there's one over here. And then there's one over here. So you may be thinking that there's 4. But no, there isn't. Because there's a sneaky one at the back. Whew. So 1, 2, 3, 4, 5. There's 5 vertices. Now we move on to edges. Finally, we're almost at the last part of this problem, but we have another problem ahead. Whew, we can do this. Anyways, so where do 2 faces meet? Well, we know that the triangle and the square meet here. That's 1. We know that another triangle and a square meet here. That's 2. And we know that another triangle and a square meet here. That's 3. But there's also another triangle back here hiding that also meets with a square. So that's 4, because a square. Anyhow, and then 2 triangles meet here. 2 triangles meet here. 2 triangles meet here, but that's not all because there's those 2 sneaky triangles at the back. So 2 triangles also meet here. So that's 1, 2, 3, 4, 5, 6, 7, 8. It has 8 edges. And because of our hard work, we now know that a pyramid has 5 faces, 5 vertices, and 8 edges. Now we move on to the second question. That's a rectangular prism. Doesn't it remind you of the blocks that you play with? Yeah. So, now rectangular prism, it kind of looks like a room, right? Because we all know that rooms aren't perfect squares, usually. They might be though. So how many faces are there? Well, how many walls are in a room? You may say there's 4 walls. And yeah, there are 4 walls in a room. But remember that the bottom and the top of the room also counts. So, how many faces are there? Well, we have the 4 walls. And then we have the ceiling and the floor. So, 1, 2, another 2. So then 4 plus 2 is 6. There are 6 faces. Now we move on to vertices. How many corners are in a room? Remember I said there's 4? Well, no, I said that people think that there's 4. But there's also the ones on the top that we can't float into and hide in. So what's 4 plus 4? 1, 2, 3, 4, 5, 6, 7, 8. 4 plus 4 is 8. So there's 8 vertices, as you can see in that diagram. And 2 of these vertices look like they're 1, but this is actually 2, since one of them is hiding behind because they're sneaky. And finally, we're at edges. Yay, we're almost done this exercise. So, there's this one over here, one over here, one over here, and one over here. So 4 places where the walls of a rectangular prism would meet. But then there's a wall, every single wall in the floor. Does every single wall meet the floor? Yes. Does every single wall meet the ceiling? Yes. How many walls are there? 4. So if 4 walls meet the floor and 4 walls meet the ceiling, that would be 8 places where they meet. And then that's 8 plus 4 where the walls meet each other. So 8 plus 4 equals 2. Come on, we learned this before. 12. So now, because we worked for it again, we know that rectangular prisms have 6 faces, 8 vertices, and 12 edges. We're at the last question of the section. Come on, guys, we can do this. Find the figure that has 1 face and a point. Color it blue. Now, I need to tell you something very interesting about faces. Listen up, guys. Faces have to be flat. So, you know that lovely soccer ball that you really like? Well, that thing has no faces because it's not flat, or else the soccer ball wouldn't really roll that well. Have you ever tried to roll a block? It doesn't get very far. Now, since faces have to be flat, and we know that rectangular prisms and cubes in previous examples both have 6 faces, and it's definitely not these 2. And pyramids, from question number 1, have 5 faces, so it's not this one either. Now, cylinders have a circle at the top and a circle at the bottom. So that's 2 faces, so it isn't a cylinder either. And then spheres, as I said, no faces. So it's not a sphere either. Now, the only one left is a cone. And the face is right here at the bottom, which is a circle. And what do you know? A cone also has 1 point. Now let's color this one blue. The question asks us to. Woo. Question number 4 asks us to find the figures with the same number of faces and color all of them red. So we mentioned that this one has 1 face, this one has 2 faces, this one has no faces, and this one has 5 faces. And these 2 both have 6 faces. Is 6 the same number of faces as 6? Yes. Now let's color these guys red. Woo! Because the question tells us to. Coloring it red. So, the last one tells us to circle the figures that can roll. That depends on how much you want to roll them. Because if you really want to argue, most of these can roll. It's just how far they roll. If you've ever tried to roll a cube, you do know that it goes a little bit, but it doesn't go far at all. So, let's circle these. So we know that balls can roll, so spheres can roll, so we definitely know that this one can roll. And if we've ever rolled a soda can or a pop can, we also know that those can roll. And if you've ever rolled a party hat or had your ice cream fall on the floor, then you know that cones can roll, it's just that they roll like this. They don't roll in a straight line. They roll around the point, and they just keep going until they stop. Just like a ball, it just keeps going until it stops. So technically this one can also roll. Finally, we're done the last activity of the section. Give a cheer for yourself. Now we're on section number 3. Hooray! Where we'll be teaching you about plane shapes. Personally, I like it better when we teach plane shapes before solid shapes, but this is how it goes. So a plane shape is a two-dimensional shape with only length and width. So why is it called two-dimensional shape? Because length and width, there's only 2 measurements. So that's length, width, 2. Now you might be wondering, what about solid shapes? And why are they called 3-dimensional? Well, because solid shapes have height. And why don't 2-dimensional shapes have height? Because they're flat. They're so flat that they don't have height. Now, we have the common ones, the circle, the square, and the triangle, which we've been learning about since kindergarten. And the rectangle, we also learned that in kindergarten too. And then there's the hexagon, which everybody draws beehives with. Then there's a trapezoid and the parallelogram, which some people might call a diamond. Now, a diamond is slightly different. We'll be teaching you that later. So the trapezoid may look something like this, or it might look something more like, well, this. But trapezoids come in many shapes and forms, and the reason why it's called the parallelogram, it's called a parallelogram, is taught to you later, much later. Now, you might be wondering, why is a triangle called a triangle? And why is a hexagon called a hexagon? Well, that's what I'm going to explain to you right now. Many teachers might not explain this to you, but I like doing it. So, I'm sure we've all rode a bicycle or a tricycle, right? Now, what's the difference between the two? Well, a bicycle has 2 wheels, and then a tricycle has 3 wheels. And maybe you've seen a unicycle somewhere in your neighborhood, or on TV, or in a book. And a unicycle has 1 wheel. Now, this is what I'll be teaching you. Uni means 1, bi means 2, and tri means 3. So by this point, you might be wondering, what about 4, 5, and 6, and 7, and 8, and so on, so on, so on? Well, for 4, we have quad. And then blah, blah, blah. And then, depending on what you're using it for, you might have quint, such as quintillion. Note that the word gazillion doesn't actually really exist in math terms. We have billion, trillion, quadrillion, and then we have quintillion. But for shapes, we have pent, such as pentagon. And then we have hex for shapes. We're just going to go with shapes now, which is why the hexagon is called the hexagon, because it has 6 sides. Then there's sept. This is actually how you spell 7 in French, but that's octa. So octopus, octagon. This might be octo, but in math it's octa. Nona. And deca. So then we don't have a bigone because you can't make a shape with only 2 lines. If you've ever tried, you know that it doesn't work. So we have the triangle, we have quadrilaterals, which is a big family of 4-sided shapes, such as the trapezoid, the parallelogram, the rectangle, and the square up there. We have the pentagons, the hexagons, the septagons, and octagons, the nonagons, the decagons, and so on, so on, so on, so on, which we won't be going into right now. So now, we're going to do an exercise on if we can or cannot identify these shapes. So what shape is this? First we ask ourselves, how many sides does it have? Well, 3. What is the thing that in math that we usually use to describe 3? Or in this case, what is the prefix for 3? This is what you learn in English. Well, the prefix for 3 is tri. So then this would be a triangle. What's this shape? Well, it's that weirdish shape that we learned before from this to be a trapezoid. So this is a trapezoid. This is a rectangle because, well, the difference between a rectangle and a square is that the square has all equal sides and the rectangle doesn't have to. The length and the width of a square is equal, but the rectangle, well, it doesn't have to have an equal length and width. So, is the length and width of this shape equal? No. Therefore, it's a rectangle. Now this one is the one that you might have called a diamond before, but it really isn't. At least not in grade 2 anymore. It's a parallelogram. I know that a parallelogram is a bit of a mouthful to say, and it's a little difficult to spell when you first learn it, but don't worry, you'll get it soon enough. And then there's a 6-sided shape. What's the prefix for 6? Hex, hexa. So it's a hexagon. Now we're done section number 3. We're finally done that. And now we're at section 11.4. Well, section 4 of chapter 11. Where we teach you about problem solving and take a break from all those shapes. Or do we take a break from all those shapes? Problem solving strategy. Finding a pattern. Now I'm sure you've been finding patterns ever since you were in grade 1 or maybe even kindergarten because you guys are all smart children. But we're still doing this in grade 2. So just bear with me. Dee is making a pattern out of blocks. She places a cone, a cube, a pyramid, a cone, and a cube. What block comes next? So the first step to any question is understanding exactly what you know and exactly what you don't. Well, you might not understand what you don't. You just have to understand what you do know and what the question is asking for. So, what do I know? Well, B is making a pattern, so what do I know? There is a pattern. And we also know that the pattern is a cone, a cube. Oh, that doesn't look like a very pretty cube, but a pyramid, a cone, and a cube so far. So, what do we want to find out? Now, some teachers will ask you to look through the entire question, but honestly, usually at this point, at this grade level, you just need to look at the sentence where the question mark is. So, what block comes next? What do I need to find out? What block comes next? Straightforward, right? Now, step 2. We plan how we're going to actually solve this question. How will I find the block that comes next? Well, usually when there's a pattern, you find which part of the pattern repeats itself. So when you know what part of the pattern you repeats itself, and you know which part of the pattern you're at, then you know what is next in the pattern. Step 3, you solve. You find the pattern. So let's go back here. There's a cone, there's a cube, there's a pyramid. And then there's a cone and a cube again. So we know that there's a cone and a cube, and then there's a cone and a cube here. And then there's a pyramid after. So it's only safe to think that the cone, cube, pyramid is what is repeating itself. So now we can solve the question. What shape comes next? So since it's cone, cube, pyramid, and we're at cone cube, then what's next? Pyramid. So what shape comes next? Pyramid. Now the word pyramid may be hard for some people to remember how to spell, but it's okay. You get it soon enough. And now we check. We can't really check answers for these type of things unless we plug it in and then we see if it makes sense. That's as far as checking would go. Does my answer make sense? Well, we went through this entire process. And if we put in pyramid here, it's cone cube pyramid, cone cube pyramid. So yeah, your answer makes sense. And can you check your answer? Well, you can by putting it in there and seeing if it makes sense. Now we're done the problem solving section. Whew. So now we're still at chapter 11, but we're on section 5 now. So today we will be teaching you about sides and vertices of flat shapes, or plane shapes, or two-dimensional shapes, whatever you want to call them. So the sides are, well, the sides of the shape. There's not much more to it. And the vertices are also the corners. Now that's easy to understand, right? So let's see if you do actually understand this. And let's do some practice problems. So write how many sides and vertices for each of these shapes. What shape is this? All sides are equal. There's 4 sides. It's a square. So let's count the number of sides. I just said all sides are equal and there's 4 sides, so it's pretty obvious that there's 4 sides. But we're going to go through this anyways. 1, 2, 3, 4. 4 sides. And how many corners are in a square? If you've ever been in a room before, this is the amount of corners that you could actually hide in. 1, 2, 3, 4. So then there's 4 vertices. The concluding statement for this would be, in a square, there are 4 sides and 4 vertices. Done. Now we move on to the hexagon. The lovely, lovely hexagon. How do we know it's a hexagon? Because it has 6 sides. How do we know that? Because we counted. 1, 2, 3, 4, 5, 6. And then we count the vertices. 1, 2, 3, 4, 5, 6. 6. Now the interesting about flat shapes, plane shapes, two-dimensional shapes, whatever you want to call them, is that the number of sides is equal to the number of vertices. Unless there's curved sides, because then you can't really say that that's a side, since sides in grade 2 are flat, just like faces are. Now this one. Let's count how many sides there are, shall we? 1, 2, 3. 3 sides. That's a triangle right there. So we put on 3. And then we count the number of vertices. 1, 2, 3. 3. The vertices are also where the angles are, but that's for another discussion. And then this one. We have this 1, 2, 3, 4. And it looks kind of like the diamond shape that you use in those building blocks. So there's 4 sides. And since we don't really call them diamonds anymore, we call them parallelograms. That's a parallelogram. And then 1, 2, 3, 4 for vertices. So then 4 sides and 4 vertices. Since the number of sides and vertices are equal, we don't actually really need to count that, but we still would for understanding purposes. Now, this is that weird shape that we learned was called a trapezoid. So 1, 2, 3, 4. 4 sides. There are 4 sides in a trapezoid, and 1, 2, 3, 4. 4 vertices. Yay, we're done that section. That was quick, wasn't it? You guys still have enough energy to continue? Let's go. Chapter 11, section 6. Relate plane shapes to solid shapes, which we've been doing for the past few sections. You can trace the face of a solid shape to find a plane shape. Find a plane shape. Wow, right? It's not like I told you a few sections ago that there was a circle on the top of a cylinder and another circle at the bottom. So see, the two faces of the cylinder are circles. This is what they tell you right here. So since we've been doing this for, well, the past few sections, you guys are smart. So you should be able to do some of this, right? Alright, so then let's do this. Now you might not be able to see the shading very well on your screen, but this is the one that's shaded. Can anybody tell me what shape that is? It's a pyramid, right? What type of pyramids have we been learning about so far? Square-based ones. So you would assume that the base is a square. However, we should have better reasoning for that. So if we take that out and put it here, it would look something like this. Now that looks like a parallelogram, but it isn't. Because as I have said before, these are 3D drawings, and 3D drawings kind of look a little bit wonky, bizarre, strange, whack. Add that to your vocabulary. So there's 4 sides. Does any of these shapes have 4 sides? This one. The other 2 have 3 and no sides because a circle is a big curve. Now, the second one. This one is the side that is shaded. Now that looks like a parallelogram, but it isn't, because that's a rectangular prism. And we all know that rectangular prisms are made out of rectangles. So it's definitely not a triangle since there's 4 sides, but it's not a parallelogram because it's a rectangular prism. So it's a rectangle. Now this question number 3, is easier than question number 2. It's this shape. It has 4 sides. This one is a circle. Circles do not have sides, or at least do not have flat sides. So it's not a circle. This one has 5 sides. So we learned a few sections ago about the naming of, well, these shapes. What is the name of a shape with 5 sides? Well, bi is 2, tri is 3, quad is 4, and we said quint was 5, but for shapes, it's another word. What word is that? Come on, guys. I know you know this. You can do this. It's penta. So this is a pentagon. And a pentagon is definitely not anywhere in a cube and has 5 sides anyway, so it's not this one either. We are left with this one. That is our beloved cone. So the shaded side is this one. Face is this one. Since cones only really have one face, and that one face is a circle. So it's this. Besides, it doesn't have any flat sides either, so it can't be these 2. We're done that section now. If we still have enough energy to keep going on, I trust that you do, because we are energy-filled people. Section 7. Make new shapes. Ooh, creation, creating things. Nice. Preparation. You might want to use some pattern blocks, or you could just get a piece of paper, or you could do this in your head. Whatever works for you. But many people find pattern blocks helpful. Here's an example. Use triangles or squares to make new shapes. So now we see 2 triangles can make a something with 4 sides and 4 vertices. So let's outline this. Aha! Now that's definitely not a square. It looks kind of like a squished square, actually. And it kind of looks like those diamonds, or those things that you used to call diamonds in your bag of building blocks. So it's a parallelogram. So 2 triangles can make a parallelogram. Gram. Two squares can make a, well, let's outline this one now. Something with 4 sides and 4 vertices. So this one looks kind of like a square, except the lengths and the widths aren't equal. So it's a rectangle. So two squares can make a rectangle. Amazing what you can do with, well, other shapes, isn't it? Voila! We're done the example. So now let's move on to some exercises. Yay, exercises, right? Problems. Use triangles to make more new shapes. Question number 1, make a trapezoid. Now, if you don't have anything to draw with and you are just cramming triangles with other triangles and hoping that it works, it doesn't really work. It's not that easy to do. So first, let's draw a trapezoid because now we know what the triangle has to make. So since we know that two triangles can make a parallelogram, and a trapezoid kind of looks like a parallelogram plus another triangle, then the parallelogram, the trapezoid made out of triangles, would kind of look like that. So how many sides are in a trapezoid? Well, a trapezoid is one of those shapes with 4 sides. And since the number of sides is equal to the number of vertices, there's also 4 vertices. So the second question is for us to make a hexagon. And hexagons have 6 sides because hexa stands for 6. So by this point, it might get a little hard because you might be wondering, well, how do I do this? You might see this, but a hexagon looks like it's made out of 2 trapezoids. And since a trapezoid is made out of 3 triangles, well, there. Now, this looks like a really strangely shaped pie now. How many sides are in a hexagon? Well, hexa stands for 6, so there's 6 sides. And how many vertices? Well, the number of vertices is equal to the number of sides. So, 6 vertices. That is a very loopy 6. We're finally done section number 6, and now we're moving on to section number 8. It's the last section, guys. If you're tired, hold on. I believe you can hold on. Teach. Problem-solving investigation. Choose a strategy. Choose a strategy to solve. So the problem-solving strategies that they included for us here includes draw a picture, act it out, and guess and check. There's also another strategy. Call upon prior knowledge. It's like 2 plus 2. You don't need to act it out. You don't need to go like 2 plus 2, 1, 2, 3, 4. You don't need to draw a picture either because you already know that 2 plus 2 equals to 4. And you don't need to guess. It's like, does 2 plus 2 equals to 3 or does 2 plus 2 equal to 4? Does 2 plus 2 equal to 5? And then you check. You don't need to do that. It's called prior knowledge. What you have known prior or before to this question. Lau has to design a robot for class. That is one cool class. Why don't we get to do that? Using solid shapes with 6 faces. What shapes could he use? So, what shapes have we learned about before? Well, we know that there's a cone, but a cone only has 1 face. There's also the cylinder, but the cylinder only has 2 faces. There's also a sphere, which has no faces. And then there's the pyramid, which has 5 faces. And a few exercises before, we had colored the shape with the same number of faces, which also was 6, red. And we know that rectangular prisms and cubes, which are shaped like rooms, have the 4 walls and the ceiling and the floor. So 4 plus 1 equals to 6. Now we found our 2 shapes with 6 sides. What shapes could he use? So we're going to write down the answer. He can use cubes and rectangular prisms. Done! That's it for question number 1. Now we move on to question number 2. Fran's mom gives her an object with 2 faces shaped like circles. Is the object a cake or a party hat? Explain your answer. What does a party hat look like? It looks like an upside down ice cream cone. What does an upside down ice cream cone look like? Oh wait, hang on. Let me make it look nicer. Well, it looks like a cone. And a cake can look like many different things. But if there's 2 faces shaped like circles and there's only 1 face in a cone, then we definitely know that it's not a party hat. So the object is definitely a cake. Even though cakes can come in many different shapes and sizes. So, explain your answer. We need to explain it. So, our explanation is that it can't be a party hat because cones have 1 face. So, the answer would be written something like this. It is a cake because party hats are cones, which have 1 side shaped like a circle. Now that's done. Now we're at question number 3. 2 numbers have a sum of 12 and a product of 35. What are the numbers? This is kind of like algebra. So let's call the numbers n and m because we don't know what they are. So n plus m equals to 12. And n times m equals to 35. Now, well, you see, many things can equal to 12, but not many things can multiply to 35. If you know your times tables, you would know that 1 times 35 equals to 35, or 1 times anything equals to the thing. And 5 times 7 equals to 35. But 1 plus 35 is not 12. But what is 5 plus 7? 5 plus 7 equals to 12. So 5 plus 7 equals to 12. 5 times 7 equals to 35. That fulfills the requirements. So the numbers are 5 and 7. We're done that. Toby cuts 2 triangles, this is question number 4, out of paper. What is one shape he can make with them? Now, well, you can act this out, or you could draw it. But the efficient way would be remembering that a few sections before, we learned that 2 triangles can make a parallelogram. So, he can make a parallelogram. That's it. Question number 5. Jan makes a shape out of cardboard. You could get cardboard and actually do this, or you could do paper, or you could think of it using, well, your prior knowledge. It has 6 faces. So in question 1, we already know that solid shapes that have 6 faces are cubes and rectangular prisms. There's only 2 choices. Some faces are longer than others. A cube is made out of squares. Squares have all sides of equal length. It has 12 edges and 8 vertices. What shape has she made? This part, it doesn't really matter since we already know it has 6 faces and both of the shapes fulfill that requirement. And the moment that you hear that it has 6 faces and that some faces are longer than others, we already know that it's a rectangular prism. So, she has made a rectangular prism. Jan made a rectangular prism. Make sure you answer in full sentences, because if you don't answer in full sentences, some teachers will actually take marks off. Question number 6. Two numbers have a difference of 2 and a sum of 16. What are the numbers? There are many numbers with a difference of 2. 3 minus 1 is 2, but 3 plus 1 is not 16. So first we think, what are some numbers that equal to 16? 10 plus 6 equals to 16, and 10 minus 6 equals to 4. Oh, wow, we're close. And we also know that 8 plus 8 equals to 16, but the difference between 8 and 8 is, well, 0. So then we think, what? 9 plus 7 also equals to 16. And 9 minus 7 equals to 2. So 9 and 7 have a difference of 2 and a sum of 16. That fulfills the requirements. The numbers are 9 and 7. That's it. Chapter 11 is done. Congratulations. See you next week.